Meet Chuck, who operates a very large cold storage facility filled with frozen food. Now, while Chuck makes a profit, sometimes he knows he can do better. He's just not sure how. The nagging question is, why does it cost so much to run a refrigeration system? Refrigeration is over half of Chuck's energy bill, and it's the half that just keeps growing. What to do? Well, you certainly can't lower your cooling costs by raising your temperature. Turning off lights saves energy, but only goes so far. Chuck decides to call in the cavalry and gets experienced help with refrigeration and energy management. He calls on Cascade Energy. Now, Cascade knows Chuck knows cold storage, but has he ever considered the physics behind it? No? Well, that's the key to saving energy. Chuck is intrigued. He learns that everything has energy. Heat is energy. When things cool, they lose energy, and when they warm, they gain energy. And like Chuck in a cold room, heat flows out of his body. In a warm room, heat flows into his body. It's a principle of physics. Energy always flows from a high-energy warm state to a low-energy cold state, sort of like water flowing downhill. Which is what happens at Chuck's. Heat wants to flow from the warmer outside to the cooler inside of Chuck's cold storage. Only Chuck doesn't want that. And of course, the heat's always trying to get back in, especially with people and product moving in and out. Energy heat comes into the cold storage through the walls, through the doors, from warm product, from forklifts, even from the lights. Refrigeration systems work to reverse that process, moving energy or heat from inside to outside. Again, just as a pump is needed to move water uphill, a refrigeration system is needed to move energy from inside Chuck's freezer to outside his building. Remember our physics? Energy moves from a high state to a low state. Well, refrigeration systems move the heat out by creating a place the heat naturally wants to go to, that low-temperature sink such as the evaporator coil in a cold storage room. That's because the refrigerant inside the coil is cooler than the room. The heat in the room goes right for it and gets pumped out along with the refrigerant. Outside, the refrigerant is compressed until it's warmer than the outside air. And what happens when something is warmer than the environment around it? It loses heat. Fans and more tubes are used to speed the process, so the heat that was inside Chuck's is now outside of Chuck's, all thanks to a simple principle of physics. Not necessary, not at all. What costs money is the energy required to move energy or heat. In a refrigeration system, most of the energy is used in evaporator fans, compressors, and the condenser fans. The way they're used and the way the system is designed and operated affects how much energy is used and money spent. At Cascade Energy, we're experts at showing clients like Chuck how to design and operate systems that are energy efficient, driving down energy costs and increasing profits. Energy costs can be reduced by installing more efficient equipment, but can also be improved with low-cost or no-cost changes to the way equipment is operated. Want the same for your facility? Do what Chuck did. Click or call today. In a hurry? Ask about our energy tune-up.